Alright, so today we're going to be talking about applications of quadratics. So this lesson basically uses all the skills we've developed with quadratics, solving and factoring quadratics, and it applies them to real-world situations. So there's it's basically word problems with quadratics, and it also involves some geometry applications. So you'll see some of the stuff you learned in geometry come up a little bit here. So let's get started. So the first question says, the base of a triangle is 7 less than twice its height. If the area of a triangle is 102 centimeters, find the length of its base. So the first thing we need to know in order to do this problem is, what is the formula for area of a triangle? You got it. So of course the area for a triangle is equal to 1/2 base times height. Also base times height over 2, same thing. Okay, either one's correct. And then once we have that information, we're now going to set up our let statements, okay? So there's 2 dimensions of the triangle that we need to worry about. We have our base and we have our height, of course. So we want to write one of them in terms of the other. So it says here the base of a triangle is 7 less than twice its height. So let's call height by the letter H. And if height is the letter H, we know the base is 7 less than twice its height. So we would take height and multiply it by 2, and then subtract 7 from it, and that would give us our base. Okay, does that make sense how I wrote that out? Okay, so you just do an interpretation of the words basically with an expression. So the base of the triangle is 7 less than twice its height. And then of course we have the information that the area is equal to 102 centimeters. So I'm just going to let you know in advance, I leave the units off during the math problem and then I put them on at the end. It's just easier to not have a messy problem. And then from here I'm just going to plug in for each of the variables here. So area is equal to 102. The base is 2h minus 7, and the height is h, all over 2. Now over here, I'm going to use distributive property. Okay, it's kind of weird with the monomial being last, but you're just going to distribute, and that's going to be 102 equals 2h squared minus 7h all over 2. So that's what we have so far. Now, how can I get rid of this 2 in the denominator? Yeah, I can multiply both sides by 2, right? That cancels out the 2 in my denominator, and that leaves me with 204 equals 2h squared minus 7h. Now you're starting to see it's got the form of a quadratic. So how can I get this into standard form of a quadratic? Good, I can subtract 204 on both sides. And when I do that, I'm left with 2h squared minus 7h minus 204 is equal to 0. So now, anybody have any questions up to this point? Anything that we did? Okay. So from here, you're going to factor it however you see fit. In this case, you can use the AC method. The only issue with using the AC method here is it's a really big number to find factors of, 408. So it can take a while. So what's another option that we could use that works for everything? X equals negative b over 2a, that one? I'm not negative b over 2a. X equals negative b plus or minus square root of b squared. What's that called? We can use quadratic formula here. We can use quadratic formula. So in order to use quadratic formula, we have to be in standard form, which we are, and we have to know a, b, and c. So what is a here? And b? Good. And c? Good. So now from here we can use quadratic formula. Okay? So that's x equals Now if b is already negative, it becomes positive, so positive 7 plus or minus the square root of negative 7 squared minus 4 times a times c all over 2 times a. This room is so hot, isn't it? Like, I literally feel like... So, we're just going to simplify this. So this becomes x equals 7 plus or minus the square root of 49 plus whatever that multiplication is, 4 times 2 times 204. I'm getting 1,632 all over 4. I'm going to combine underneath the radical, and I get x equals 7 plus or minus the square root of 1,681 over 4. And then I simplify that again, and I take the square root of that, and that is actually 41. So this would have actually factored. It's just sometimes it's going to take you a while to factor that, so this is a faster way if it's going to be something complicated. So the two versions of our solution here are x plus 41 over 4 and minus as well. So
solve further.
Here?
Yeah.
So whenever you get to this stage where you have a number, and a number, or a radical, with the plus and minus, you just write it as two separate solutions, and yes, both of these we can solve further.
Yeah.
So 7 plus 41 divided by 4 is 12, and 7 minus 41 divided by 4 is negative 8.5. So these are the two solutions I got. Because it is a quadratic, you will get two solutions sometimes. However, one of these solutions is not useful to us. You guys tell me which one is not? Good, the negative one. Because why can't the answer be negative here? Yes, but have you ever heard of a negative measurement? No. Measurements are not possible to be negative. So this is what we call an extraneous solution. I know these come up in geometry as well, so you've seen it there, but basically this just means that this solution is mathematically correct, but it's not correct with the context of the problem, because this is a real world problem, and real world has constraints like negative measurements don't exist. So your x value here is 12. So if I go back up here, this means that my height, basically we solved for h, we turned h into x, this is 12. But the question didn't ask about the height, it asked about the length of the base. So how can I find that now? Yeah, I can just plug it back in. So 2 times 12 is 24, 24 minus 7 is 17. And of course, at the end, you can always check your work. 12 times 17 is 204. Oh, divided by 2. Yeah, you got divided by 2. I'm like, wait, what? Yeah, so it does work out. If you do 7 times 12 divided by 2, that would be 102. So don't forget to put your units on these. Okay, very important. Both the measurements have to be in centimeters. Does that make sense so far? All right. And I will have you put a star on this question, because this is the kind of question that might be on your test or quiz, FYI. Okay? So some of these word problems are going to be things that will be on the test or quiz, more similar to those kind of questions. So I'll give you a little bit of a hint here. So this question says, the length of a rectangle is 6 meters less than its width. Find the dimensions of the rectangle if the area is 27 square meters. So first thing we need to know is, what's the formula for area of a rectangle? Good. area of a rectangle is base times height, also known as length times width. Either one is fine. I'm going to use length and width here, just because that's the context they use in the question. So I want to keep it consistent so we don't get confused. Now we want to figure out what the length and width actually are in terms of variables. So I'm just going to use x here. So it says here, the length of a rectangle is 6 meters less than its width. So I see the length is in terms of the width. So I know the width is just going to be a variable, and I will use x here. So we'll call the width x. And now that I have a variable for width, I can write length in terms of what width is. So 6 meters less than its width. So how would I write that as a mathematical statement? Good, x minus 6. Think about it as, when I think about this in my head, I think, what's a real number, and then 6 less than that number, and then I can help think of how to set up that expression. So now I have length and I have width, and I also have area, so I'm ready to plug everything in. So 27 is equal to length times width, so it's like this. I'm going to use the distributive property here. So this gives me 27 is equal to x squared minus 6x. We subtract 27 on both sides, and we get x squared minus 6x minus 27 is equal to 0. And now from here I need to factor this. So what are some factors of 27 that add up, or negative 27 that add up to negative 6? Good. Negative 9 times positive 3. Up?
Yep. If we wanted to, could we use the quadratic formula, or do you have to do this?
No, you can always use the quadratic formula if you want to.
Okay.
So then from here, you're going to set each of these equal to 0. Remember how you do that? So this becomes x minus 9 is equal to 0, and this becomes x plus 3 is equal to 0. We add 9 to both sides, and we get x equals 9. And we subtract 3 from both sides, and we get x equals negative 3. So of these two solutions, which one of them am I going to reject? Good, because measurements can't be negative. So my x value here is 9. So scrolling back up, my width is equal to 9, but they want to know both dimensions. So how can I find the length? 9 minus 6, which is 3. And that would make for an area of 27, right? So that's how you do it. I'll have you star this question because this is a similar one that comes up on the quiz or the test, or both. I feel like this room feels like 100 degrees today. Struggling. So moving on to the next question. It says, given the diagram, if the area of the shaded region is 59 square inches, what are the dimensions of the outside rectangle? Well, let's think about what the shaded region is. Now, the shaded region is this weird shape, okay? We don't have a formula for a shape like that, do we? But we do have a formula for the large piece and the small piece. So we can use subtraction here. So if I find the area of this whole thing right here, and then I subtract away this piece, that will give me the area of just the shaded region, right? Does that make sense how I'm phrasing that? So we're going to use that to figure it out. So first, in order to do this, we need to find the area of the whole thing, and then we can subtract away the smaller piece. So how could I represent the area of this whole big rectangle here? What times what? Good job. X plus 6 times 2x minus 1. And then whatever this area is, I need to subtract away this area of the little rectangle, okay? So minus, now this is where you got to be careful with double parentheses, because we need to make sure we're subtracting this whole thing away. Parenthesis, x times x plus 3. You got the double parentheses. Equals, we know the area of the shaded region is 59. So we represented the shaded region in terms of the variables, and now we can actually compute. So the first thing I'm going to do right here is FOIL. So this becomes 2x squared minus x plus 12x minus 6. And then this is minus, and then I'm going to distribute on the inside here, x squared plus 3x equals 59. Now whenever you're subtracting a polynomial of any type, you need to distribute that -1 to all the terms. So this becomes 2x squared minus x plus 12x minus 6 minus x squared minus 3x is equal to 59. And then this looks complicated, but all we have to do here is just combine like terms. So 2x squared minus x squared is just x squared. Negative x plus 12x is 11x. 11x minus 3x is 8x. Good. And then my only constant is -6, so I can't combine that with anything. And then I get to this stage, and I'm almost in standard form, but how can I get fully into standard form here?
Add 6 to both sides. Do you add?
Yeah, we got to subtract 59. Your math isn't wrong, it just wouldn't get us where we want to be.
Yeah.
So this is x squared plus 8x minus 65 is equal to 0. Now from here, we're going to look for factors of -65 that add up to 8. Any ideas? 5 and 13. It's 5 and 13. So the 13 is going to be positive and the 5 is going to be negative, because that's what's going to make a positive 8 when I add them. And then from here, I'm going to set each of these equal to 0. And when I do that, I'll just skip to that part. You guys get it by now. X equals -13 and x equals 5. So I just set each of these binomials equal to 0 and solve, which changes their sign. Now which one of these am I going to reject? Good, that's an extraneous solution. The only one that we care about is the 5. So we move up to the top, and now I have 5, which is x. Okay, x equals 5. And they want to know, of course, read what the question wants. What are the dimensions of the outside rectangle? Well, in order to do that, I'm just going to plug x in for both of these. So this is going to be 11, and then this is going to be 9, because I just plugged x in. Make sense? So if you wanted to check your work at this point, you could plug in the x's on the inside one as well, which would give you 8 times 5. So the outside rectangle would be 99 square inches, and the inside would be 40 square inches. 99 minus 40 is 59. Now don't forget, when you put these dimensions on, you need to put units. I don't know why I'm putting centimeters, because it's inches, but you got to put units. And these are both in inches, according to the problem. And that would be your answer. Any questions so far on this? Okay. So this question says, it's a geometry question again. The hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. Oops. So we take our triangle, we draw it. And when we talk about hypotenuse and legs, we know it's going to be what kind of triangle?
A right triangle?
A right triangle, because the right triangles are the only triangles that have a hypotenuse. So, the hypotenuse is the side opposite the right angle, as you guys know from geometry, and these are the two legs. So let's go ahead and write some statements. So let's write everything in terms of the shorter leg, because that's the one that we're referencing to talk about the other ones in terms of. So let's call the shorter leg x. Now the next dimension that we mentioned for the sides is the hypotenuse. So it says here the hypotenuse of the triangle is 1 foot more than twice the length of the shorter leg. So how would I represent that as an algebraic expression? Good, 2x plus 1. And lastly, we have our longer leg. And the longer leg is 7 feet longer than the shorter leg. So how do we represent that algebraically? You got it. Now, we need to find the dimensions of the triangle. So does anybody remember a formula to find a side of a right triangle? A squared. Exactly. You guys remember Pythagorean theorem now that I say it? So in Pythagorean theorem, I'll just give you a quick refresher on how this formula works. A and B represent the legs. It doesn't matter which one is A and which one's B. The only one that has to be C is the hypotenuse. Okay, hypotenuse always has to be C. So A and B are the shorter legs, the two legs, shorter or longer. So I'm going to just do the shorter one, A. So this becomes x squared plus the other leg is equal to the hypotenuse. And don't forget everything is squared here. So I'm going to have to rewrite this. This becomes x squared plus x plus 7 times x plus 7 equals 2x plus 1 times 2x plus 1. Somebody get the door for Janelle. So now from here, we're going to use FOIL to simplify this. So this becomes x squared plus x squared plus 7x plus 7x plus 49 equals 4x squared, these are the outers, plus 2x plus 2x plus 1. So it looks like a lot, but now we're just going to combine like terms here. So x squared plus x squared is 2x squared. 7x plus 7x is 14x. And then I don't have any other constants on this side. And then over here I have 4x squared plus 4x plus 1. Now we're just going to move everything to one side of the equation. So I try to go where the x squared is not going to be negative. So I'm going to subtract everything to the right. So I subtract 2x over. I'm going to subtract 14x over. Now you can do this in multiple steps if you feel more comfortable with that. I'm just subtracting it all in one step here. I subtracted everything over. And that's going to leave me with 2x squared minus 10x minus 48 is equal to 0. And that's the point we get to. And now we need to factor this because we're in standard form. So what can I factor out of each term here? What's the GCF here?
2.
Good. So this is going to become x squared minus 5x minus 24 equals 0. And then this is going to factor into two binomials. So what are some factors of negative 24? Good. Thank you. Yeah, negative 8 and positive 3, right? And then from here, you just set everything equal to 0. 2 equals 0 is just null. No solution on that one. We set these equal to 0. This is the zero product property. We talked about that. We add 8 to both sides, and we get x equals 8. And over here we get x equals -3. And these are my two possible solutions. Now, which one of these am I going to reject? Good, because measurements can't be negative when we're talking about dimensions of triangles. So if we move up to the top here, we found x to be 8, and they want to know all of the dimensions of the triangle. So I need to then plug in 8 for all of the other dimensions as well. Yeah, so this becomes 17, and this becomes 15. I just plugged in 8 for x. And don't forget to put your units on it. In this case, it's feet. So these would be feet. And we only know it's feet because of this one. So thank you. Alright, so this question says, find 3 positive consecutive integers such that the product of the smallest and largest is 17 more than 3 times the middle. So this question sounds really confusing. Okay, when I first read it, it sounds really confusing. So I want to break it down into several steps, okay? So the first thing we want to talk about is find 3 positive consecutive integers. Let's talk about what that means. So positive integers are like 1, 2, 3, 4, numbers that are not negative, right? Not 0. And what do you think a consecutive integer is when you hear that term? In a row, yeah, so like 4, 5, 6, 7, 8, 9, those are consecutive. So let's say that our first number, okay, the first number in our sequence, let's call it by the letter x. So you always start with one of them. We're always going to call it by some generic variable, and then we're going to manipulate that variable or write it in terms of that variable for the other ones. So if my first one is x, my second one, let's think about it. Let's talk about consecutive integers. If I take the number 4, what's the number after 4? How did I get from 4 to 5? Plus 1. So the second integer has to be x plus 1. Now, how would I get to the third integer? Good, I'd have to add 2, because I'd have to add, it's 2 away from the first one. Does that make sense how we set it up? Okay. Now from here, let's go ahead and set up the rest of the problem. It says such that the product of the smallest and the largest, so that's the first and the third. So the product means multiplication. I multiply the first and the third because that's the smallest and the largest. Is, when we see that word in math, is, that means if something is something, it's equal to that, right? Your age is whatever it is, that's what it is, that's what it's equal to. So 17 more than 3 times the middle. So we take the middle integer, we multiply it by 3, and then 17 more than that would be plus 17. That would give me my number. So look over the setup. No, the reason that it's x times x plus 2 is because it says the product of the smallest and the largest. The first number represents my smallest integer, and the third number represents my largest integer, and we want the product of those two.
Okay.
So that's why I set it up that way. Now moving on, we're going to use the distributive property on both sides. That's going to give me x squared plus 2x equals 3x plus 3 plus 17. And then I'm just going to combine like terms. So this leaves me with x squared plus 2x equals 3x plus 20. And now your goal is just to get everything to one side of the equation. So I'm going to move it all to the left. Because you want to try to avoid your x squared term being negative. That's the easiest way to deal with it. It's not wrong if you go the other way. It's just going to make your life easier to go this way. So then I'm going to subtract 20 on both sides. And that leaves me with x squared minus x minus 20 is equal to 0. So now from here, we're trying to factor this. Remember, this is a 1, negative 1. So what are some factors of negative 20 that add up to negative 1?
Negative 5 and 4.
Good, negative 5 and 4. Once I have that, I set each of these equal to 0, zero product property. That gives me x equals 5, and this gives me x equals negative 4. Now we have to determine what the question asked for. Did it ask for positive consecutive integers or negative consecutive integers?
Positive.
So which one's going to be rejected?
Negative 4.
Yep, because we're looking for only positive consecutive integers based on what the problem said. So in this case, integers can be negative or positive. It's not a measurement issue, but it's a wording issue, right? So now we move up, and we know that our x is 5, our second number is 6, and our third number is 7, and those are consecutive. I would star this problem because this is the kind of problem that might come up on quiz or test. Now, I do want you to try the U-try, but I want to give you a hint first. 2 positive consecutive even integers. What are 2 even numbers that are consecutive in your head? Pick 2. 2 and 4, right? How spaced out are those numbers? How do I get from 2 to 4? 2, so I add 2. So to get from the first one to the second one, I need to add 2 this time instead of 1. Does that give you a hint here? Okay, so go ahead and try it, and I'll walk around if you need my help. Alright, so on this question here, it says the product of 2 positive consecutive even integers, a lot of words here, is 80. So, like I said before, the first integer, let's call it x, and then the second integer is a positive consecutive even number. Now, an even numbers are spaced out by 2 instead of 1 like regular integers. So it's going to be x plus 2, because that's how you get to the next even number. Like if I pick 6, the next even number is 8, 2 added to that. Now we know that the product, which is multiplication, of those 2 expressions is equal to 80 according to the problem. I'm going to use the distributive property, which gives me x squared plus 2x is equal to 80. And then I'm going to subtract 80 on both sides to get it into standard form. That gives me x squared plus 2x minus 80 is equal to 0. And then I'm looking for factors of negative 80 that add up to positive 2. And that would be positive 10 and negative 8. Which means my 2 solutions are x equals negative 10 and x equals, positive 8. So I'm rejecting this one because we are looking for positive integers according to the problem. This is a negative integer. We don't want that. This gives me my 2 answers to be 8 and 10. So this is the kind of problem that if you didn't know about quadratics, if I just gave this to a random person on the street, they could probably figure it out based on trial and error, right? But it just shows you how quadratics can model real-life situations. So let's move on to the next. You guys want to take a break before we go into this one? All right. So we are on example 6. So example 6 says, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h of x, or h of t, is equal to negative 16t squared plus 90t gives, gives the height h or height of the ball h after t seconds. So basically that's what the equation represents. How many seconds will it take the ball to reach maximum height? So this looks like overwhelming, like a lot of stuff written here, but it's actually not as complicated as it seems. So as you can see, this is a quadratic that has an a term that's negative, meaning that it goes downward. Okay, everybody with me on how we know that from the negative a we know that it's going to be going downward according to this picture. Okay? So, if we talk about the maximum height of a ball, so if you throw a ball up in the air, it reaches its maximum height. Which one of these is the maximum height? The vertex, right? So the vertex is going to help us find our maximum height. So the x-coordinate of my vertex tells me the time at which my maximum height occurred, and the y-coordinate of my vertex tells me what the maximum height actually is, like how many feet it is. Okay? So we want to know what time it will reach maximum height. Well, what's the formula for the x-coordinate of the vertex? X equals, you got it, negative b over 2a. So that's how you find the time at which the maximum height occurred. So we plug that in and we get x equals, this is negative 90 over 2 times negative 16. Which means x is equal to, so 90 divided by 32. I'm getting 2.8125 seconds. Do you guys get that?
That's what I got.
Okay. So the seconds it will take is 2.81 whatever seconds. So basically about 2.8 seconds. I'm going to leave it as its full form because we're going to have to plug it back in. So maximum height of the ball. Maximum height of the ball is the y-coordinate of the vertex. Okay, that's where the vertex occurs. So how can we find the y-coordinate of the vertex if we have the x-coordinate of the vertex? What do we have to do with that x? We have to plug it back into our equation. In this case, our x is actually t. So this is going to be h of whatever it is, x, is equal to negative 16 times 2.8125 squared plus 90 times all of that too. And that equals, oh, so gross, the numbers in this question. I'm going to just start rounding it. It's getting... Yeah, that's fine. Usually you're going to have a multiple choice question anyway, so it's going to be close. So I'm getting 125.4 feet in the air. That would be its maximum height. So does everybody understand the relation between the time of the maximum height occurring and what the maximum height is? So this is a question that is going to be on your test or quiz, by the way. Now the next question is, give the domain and range of the function. So domain is all the possible x values this function is going to take on. Now domain normally for a quadratic function is negative infinity to positive infinity, but this is restricted, right? For your domain here, the x value, is our time ever going to go below 0? No. So our domain is going to be from 0 to whatever this other endpoint is, right? Now we don't know how far the time goes. We'd have to find that value. So how can we find our x's of this quadratic? How can we find where it hits the x-axis? We have to use quadratic formula, right? We got to use quadratic formula here. So this is going to be x equals negative b plus or minus the square root of b squared minus 4 times a times c. What's c in this case? Do we have a constant in this quadratic?
It's 0.
Yeah, it's 0. All over 2 times a. So if c is 0, this whole part is 0, right?
Yeah.
Yeah, so this just comes out to be negative 90 plus or minus square root of 90 squared, which is just 90. 90 to the second power. 90 times 90 square root is 90. So this becomes x equals negative 90 plus or minus 90 over negative 32. We have negative 90 plus 90 over negative 32. And we have negative 90 minus negative 90 over negative 32. This becomes 0, and this becomes negative 90 minus 90 divided by negative 32, which is 5.625. So what this means right here is this 0 is 5.625. So that's basically the extent of my domain, right? Once the ball hits the ground, it's not going to be going any further out this way. It hits the ground, it's done. So my domain is from here, from 0 to 5.625. And the range of my function is going to be from 0 to our maximum value. So what was our maximum height? Good. So that's going to entail our range. Our range goes from 0 to that.
How come we do the brackets?
Because both of those values are included in my range and domain. Because time can be at 0 before it starts, and it can get to this time. It's included on the range and domain. Because the maximum height, we actually hit it. It's not an open circle. Okay? How long will it take for the ball to reach the ground? Well, that would be our maximum time, right? Which we just found, which is 5.625 seconds. So basically, the best way I can explain this problem to you is you got to find the axis of symmetry, which is the time at which your maximum occurs. To find where the maximum occurs, as in like what the height is, you plug the axis of symmetry back into your equation. To find the domain and range, your domain is always going to be your 0 and then your x value that you find using quadratic formula or factoring. And then how long it takes to reach the ground is your furthest out x. Do you guys have any questions on this one? You've seen these before in Algebra 1, but it's been a while. Alright. So this question says, an apple is launched directly upward at 64 feet per second from an 80-foot tall platform. The equation for the apple's height at the time t seconds after its launch is equal to this. Okay? What is the height of the apple after 3 seconds? Well, if they give us the time, what can we do with it? Yeah, we can just plug it in for t. So all we have to do is plug in for t. And that's going to be 3 times 3. Negative 144 plus 192 plus 80. I'm getting 128 feet. And then we want to know how long did the apple stay in the air. So if we think of what this quadratic looks like, okay, it goes up and then it comes back down again. So the time it's in the air is from here to here, right? So when it starts up and then it hits the ground. So how can I find this time at the end, how long it was until it reaches the ground? That's an x-intercept. Go ahead. The quadratic formula, good. So we have to use the quadratic formula here, and in this case our x is t. So this is going to be x equals, or t equals, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is t equals negative 64 plus or minus the square root of 64 times 64 plus 4 times 16 times 80 all over negative 32. So the numbers can get pretty big and all for these. So I took the square root of this and this just becomes 96, luckily. So this becomes negative 64 plus 96 over negative 32, and this becomes negative 64 minus 96 over negative 32 minus 64, so this becomes negative 1, and then down here becomes 5. So anytime you get a negative when we're talking about a real world problem like this where you're throwing a ball, you reject the negative answer as extraneous, and that means it took 5 seconds for the ball to hit the ground. So the main thing you need to know is when to use the quadratic formula, when to use the axis of symmetry, and then plug it back in. So do you guys have any questions about when to use those two things? Or do you guys understand? Okay. Alright, let's see what we have next. Alright, let's take another break because we have enough time. So for this question, basically we want to find out when the ball hits the ground. Okay, we want to find out how long it takes for the ball to hit the ground. So if my height is 0 for either one of these, that's when my ball hits the ground. So anytime they want to know when something hits the ground, you make your height 0. When I make my height 0, I need to find the factors that make that statement true for t. And this is not factorable, neither of which are factorable. So for both, I need to use the quadratic formula. When I do the quadratic formula for each one, I'm going to get two answers. I'm going to get a negative answer and a positive answer. My negative answer I'm going to reject in both cases because it's not possible to have negative time. So that's an extraneous solution. When I get my two answers, so basically, on the moon, the ball takes 12.7 seconds to hit the ground if you throw it in the air. And on Earth, it only takes 2.22 seconds. And then you just subtract those from each other, and that would give you the difference. So basically, you know how you watch those videos of people on the moon and they like bounce up and down, it like takes forever to come down? So that's why it takes so much longer for the ball to hit the ground on the moon than on Earth. It will just like come straight down. So difference in gravity, basically. The next question comes out to be much nicer numbers. Alright, I'm going to show you how this question looks. I have it up on the board if you want to see the answer. So, for the first part, you want to find maximum height of anything. Any quadratic, maximum height occurs at your vertex, okay? In order to find the vertex, you first need to find the axis of symmetry. And when you find the axis of symmetry, that basically gives you the time at which the maximum height occurs. Once you have the time at which the maximum height occurs, you have a formula that's in terms of height and time, and you can plug that time in to find the corresponding height of that time. And I get 256. So you always got to plug it back in to get the height. So the x-coordinate gives you the time at which the height occurs. The y-coordinate gives you the height. That's how you deal with maximum height. The next part of the problem says, find the time it will take for the cannonball to reach the ground. Anytime you talk about ground, that means that your height becomes 0. Because if you're on the ground, you don't have any more height. When your height is 0, we talk about that's basically x-intercept solution, same thing. So in that case, you're either going to factor, or if all fails and you can't factor, you're going to use quadratic formula. So you're basically looking for solutions. In this case, I'm able to factor because I can factor out a negative 16t, and then I use the zero product property to find the two solutions. So I get 0, time of 0, and time of 8 seconds. So of course, it reaches the ground after 8 seconds according to the math. Yes. Now let me stop my video.